Hello all and welcome to another DIY circuit breadboard build-along tutorial. Today we're going to be building the op-amp boost. I'm going to walk through each step, give a little bit of information about it, and some modification updates, some suggestions, and let's just have fun together and dive into the first step. Alright, so we're going to start at our usual, which is going to be our filtering and power section. So for step one, we're going to have a couple caps, a diode, and we're going to have our resistors for doing our VR network, or our reference voltage. So let's start right at the beginning with our D1, which is our flyback diode, which is going to prevent incorrect power being applied to the circuits. So just like we've been doing in the previous videos, we're going to be cutting our leads a little bit shorter, and I'm going to be following along directly with the parts locations that you guys have in the build guide as well. Alright, so we got D1, and we're going to go on to C1, which is our 100U electrolytic capacitor. And this is going to be, again, in our filtering section. So for the filtering, you kind of think of it as conditioning to try to help any unwanted noise, static, and that type of stuff from the power supply going into the breadboard. So let's get this electrolytic in here. There we go. As you saw, I also cut the leads a little bit shorter on that one. And the last thing we got is C3, which is our 47N. We're going to put that guy right about here. There we go. Alright, so now we've got the 9-volt rail filtering done. We need to do a VR network because this circuit has reference voltage for the op-amp. So for that, we want to check out our schematic. We're going to be looking at R3 and R4. Those are our 10Ks that are going to make our voltage divider network. So we're going to be going from the bus power rail actually into the audio rails for this. So we need our first 10K, which is R3. And we're going to put that guy right here. Alright, that's bringing 9 in. And then we're going to ultimately be going to ground on the other end. So we're going to want to actually grab a piece of black wire, and we're going to be jumping to ground right here. Just like this. Now we've got a place for R4 to get to ground easily, and also keep the breadboard pretty clean. So it'll make modding and working on it a heck of a lot easier. Alright, so second half of the voltage divider network, we're going to go from that first 10K through the next one to ground here. So you can kind of see our loop. We're also going to need a little bit of filtering from an electrolytic cap. Actually don't have to cut this shorter. Now again, electrolytic caps, they're polarized, just like the diodes. We want to look for our negative band here. That's going to go to our ground, and the positive is going to go to our voltage network. So you're going to see on the schematic it's C4, and that's going to be tying over to ground, just like R4. I'm going to do it just like this. There we go, positive leg to negative. Both of these rails are going to ground, and that is going to conclude the power and the filtering for the power for step 1. Alright, so now that we have step 1 done, we're going to jump on to step 2, which is going to be our input stage for this op-amp booster that we're making. Alright, so we're going to start right at the input. So we're going to jump from our female header and get into the breadboard area. Just like this, a little bit of green wire. From there, we're going to set our input impedance and prevent popping from the switch with our pull-down resistor. So we're going to want to find our 1 meg resistor. Remember, we've got color codes online in the build guide and on the back of the component bag itself. So we got our 1 meg. We want to tie this into ground like this. Great. Now we want to go to our input capacitor. So that's going to be our coupling capacitor C2. It's the only cap in this build. That's going to be a 0.1, and that's going to be right at the input stage. So this is going to block DC but allow our AC to go through, and essentially kind of set how much base is going to be active in the circuit. So adjusting this is always a really fun one. You could pretty much make a treble booster if you make the value low enough. So what do we got next? Alright, so next we have to get to our op amp. So I'm going to put this wire in first, and as you're going to see, I want to line up where this green wire jumps over to be right across the channel from this, since that's our VR network. This is going to actually allow our breadboard to be much cleaner so we can get over there. Alright, so now that these are lined up for this build, a lot of times you're not going to have to worry about that type of stuff, but this one's going to help in the long run. We got our other 1 meg. This is going to be our pull-up to that VR network that we made on the very first step. So once again, we're going to trim these leads a little shorter, and we're going to actually be jumping this channel with that 1 meg pull-up resistor. I'm going to use greenies here. These are our friend. We're jumping this channel. Great. So that's going to be trickling down from our VR network here that we created. So that's our reference voltage, or 4.5 for this circuit. And it's going to be distributed through R2 here into the circuit. So now what we want to do is we got to get to the op amp. And as I said in the last video, this is kind of like the core of the heart of it. So I'd like to put this somewhere first and then get all the ancillary stuff to it. So we're going to put that guy right here. Now you want to remember on op amps that they have an orientation for the pins, and pin 1 is going to be denoted by a little dot on the top left corner here. So if you see this dot here, that's how we know it's 1. It's then read 1 through 4. Across it is 5 through 8. You're going to be able to see the pinout in the build guide as well. Alright, so we have to actually get signal to the op amp, but actually wait, before we do that, we're going to power this guy. So we're going to grab some red wire, some black wire, and we're going to distribute power. This is going to be our high and low for the op amp. Power is given through pin 7, and again, let's remember 1, 2, 3, 4, 5, 6, 7, 8. So we want to get power to pin 7 like that. We want to do the same thing for the ground on pin 4. Beautiful. Now, the only thing that we have left is we have to get from the start of the audio signal, where we left off at VR, we have to get that to the input of the op amp. So the input of this single channel op amp is going to be pin 3. That's our non-inverting pin. And we're going to be going through a 1K resistor. That's going to be R5 on your build guide. And again, we got to get that over to, we're going to get this over to pin 3. So I'm going to move this green down just a touch to make sure we've got enough room. Now we can get this resistor comfortably over to pin 3. Okay, great. And that is going to be where we stop on step 2. Now that we've got to the op amp, we're going to jump over to step 3. Alright, so we're going to go into step 3, which is going to be our feedback loop and setting the amount of boosted volume for the op-amp booster. So for step 3, we're going to have a couple resistors, an electrolytic, the pot itself, and a ceramic cap and a bit of wire. So we're going to work on our feedback loop. And like I said, this is going to be determining how much boosted signal the op-amp is going to create. Let's go to pin 2 and 6, because those are going to be pretty much where everything is done, because that's going to be where our loop is. That's going to be the output, which is 6, going back to the inverted pin, which is pin 2. So you can follow along on the schematic. So what we need to do is we need to get our C6 and R7 over to another channel. So let's see, let's go with R7. That's our 47K. We're gonna jump that away from the op-amp. When you're building stuff, a lot of times you can jump over the op-amp, you can stay really close and tight. If that's how you work, that's great. For this one, we kind of want to give ourselves a little bit more range to play in. Like I said, it's also going to make it better for modding, trying out sub boxes, all of that type of stuff. And kind of just to see it, because you're gonna, if you want to come back to something, you got to get a feel for what you did when you left off. Alright, so we got R7, our 47K, we jumped over to another rail. We want to do the same thing with C6, this little ceramic cap. So we're going to widen these legs here, and we're going to follow suit exactly where the resistor went. This little ceramic cap is going to go too. And what this network is doing is kind of setting our baseline gain amount from the op-amp and doing a little bit of filtering on the higher end of the spectrum at its main state, even when the knob is at min. Okay, so what we got to do next is we have to get to pin 6, as I mentioned before, because we got to close this feedback loop. So with a little bit of wire, we're going to jump our channel from where the last two components meet and jump it straight across the audio channel like that. Then we're going to jump over to pin 6 from there. Let's get this shielding. Okay. And there. Now we've got the main feedback loop from 2 to 6 set. The last thing we need to do is actually get the potentiometer here. So what we need to do is we need to get this potentiometer placed about here. Keep in mind it's not going to be touching this rail here, all right? Because we're not actually going to be using leg 1. So we've got, just for reference, 1, 2, and 3. That's how the legs are read. What we need to do, though, is we need to get from pin 2 over to the wiper. Now remember, that's lug 3 on the potentiometer. So what we want to do is we want to bend this wire, but it's going to have to get a far enough stretch to go from the channel of pin 2 into leg 2. Now again, if you kind of go slightly diagonal, that's okay. I'm trying to keep these linear. It's going to help in the end. Now we got to go to 3. So, keeping with the potentiometer, this is lug 3, and we need to get that out to some bypass caps. But before we go directly to the bypass cap, we're going to essentially tell it the maximum it can be, which is our R6 2.2K. So even if you max out the knob, which is going to our bypass network, which is essentially amplifying and doing some EQ, this 2.2 is going to say, hey, this is our baseline no matter where you are on the knob. We're kind of making the knob be a new minimum. So out of pin 3, we want to bring this 2.2K Again, that's R6. Want to bring that over a couple channels, and then we're going to have it mate with our electrolytic cap. This is our bypass cap, which goes right to ground. This is a 4.7, also named R5 on the sheet. Remember, long leg is positive, short leg is negative. You can also tell by the color difference. You can see that it's got the stripe of silver here. Alright, there we go. Positive is in the breadboard. The negative is in our audio, or it's in our power rail negative. And that's it for the feedback loop and boost section. And all we got left is to go to the output section, and we're going to do that next. Alright, we're at the home stretch. Step 4, we're going to be doing the output stage for the op-amp boost. We've got a couple resistors, electrolytic, and some wire. So we got to get to the very output of the breadboard from the output of the op-amp. Now remember, pin 6 is our output. You can see that on the op-amp schematic, and that's where we're going to be going next with some wire. So now, little note here, this is our pin 6, but it jumps over with green wire to here, so these are essentially the same thing. So we don't have to tie in to the channel of 6 directly, we can go to this wire. And let's actually do that. So let's bend our wire. We want to get a little bit, we have essentially the home stretch here to go, so we want to keep our bent wire kind of oblong like this. Just because it's going to have to travel a little bit longer. In the build guide that you receive, you're also going to have some extra wire too, so feel free to use the extra red, extra black, any wire that you got will be fine here. The color's not going to matter, we just code it for educational purposes. So, next thing we need, we're going to R8. That's going to be a 560 ohm. We want to find that guy. Again, kind of leave a little bit more distance when we're cutting these legs, because we have to make kind of a longer trek to the audio output area. So our 560 is going to go like this. Now from there, another piece of wire, again kind of keeping that longer. That guy is going to jump out of the 560. Go right there. Now we need essentially our output capacitor. So this is our coupling output capacitor. It's polarized. It's a large value, which is great because whether you know what the signal is coming in or not, this would be great as a buffer at minimum. This is one of the modes we used to encourage on our Gravity Bomb V1, which is essentially this circuit here. So this output capacitor being a larger value is beneficial for that. Alright, so again we got polarized. The short is negative, and it's also denoted here by that stripe. And take note of how I've bent the legs here so that the bottom of it is about the same height. We know that that's our long leg. We want to go out the positive, then the negative will be here, and that's our output capacitor. We're going to also then jump out of that output capacitor with some wire so we can get to our resistor. We're literally making the home stretch here. From here, we want to use our last component, R9. That's going to be our 10K. That's going to be our pull down at the output and also set our output impedance at the end of the circuit. That's going to go directly to the ground rail. Like this. Alright, and now the last thing we need is a couple pieces of wire. Finish the race to to the output pins. And there we have it, an op-amp boost, and very modifiable. Like I said, at the input cap, it's going to be something fun to mod. You're going to probably also want to try to mess around with some of the feedback loop, the bypass caps here, and really just try stuff. That's really the name of the game here. You can even try different op amps as long as they're a single channel, and just get fun and creative with it. And thanks for building along with this DIY circuit for the op amp, and we'll see you on the next one.